Hey guys, sorry I haven't made a video in quite a while. It's about give or take almost 3 weeks now since I've done my last video here. I've updated most of the mechanical part of the machine and I'll just show you that all in a minute here. Enjoy! So I took the whole machine apart so we can clean it. Here are most of the parts. Here's a closer look at all the parts that I took out of it. It's the new Z-axis. So I finally finished the improvements I made on my old Z-axis, and I've been able to get twice the length out of it, traveling length, compared to the old one. And this is the old lead screw which I had on it, and it was fitted to this shaft which goes through the bearing, and on the other side the motor is connected to. And as you can see, it's a lot smaller than the new one. This one is 11 centimeters long and the new one is 23 centimeters long, so it's a huge improvement on that part. Now, little things I've done as well here is I had this middle screw here and I moved that out of the way and I put in 2 new screws on the side, so that gave me a little bit more of a travel length on the existing Z-axis. Now, mounting the new ones was pretty tricky compared to the old one. And the old bearing screw on the lead screw was just with a clamping block. You would slide it in and you would pressure it down the screw and it would work. I mean, this was very easy mounting system. I had to figure out a whole new mounting system for these because the bearings I had on this one were 2 separate bearings and didn't have any holes and didn't have any clamping blocks. And making one of these blocks for those 2 new bearing nuts would have been just too complicated and would have been too bulky to put on here. So what I've done, these did have threads on the top of them, so I made a plate which clamps this aluminium extrusion by putting 2 M10 bolts straight through them like this. So the plate clamps it that way and it can't move because the bolts are running through of it. And on the other side I hand tightened these bearings outwards so they just hit the plates and just got all the slack out of them so it doesn't wiggle or anything. And instead of tightening these 2 nuts on here down with force, I just put on some Loctite, tightened them down by hand, and put as much pressure on them as I could with my hand, no tools. Because if I would pressure these down with tools, it would pinch the whole assembly down and it will actually seize up the lead screw. So just hand tightening these with a little bit of Loctite did the job. And I'll put it together and show you how that looks. I've reassembled it, I've realigned these 2 shafts, and it looks to be crooked. It looks that this side is actually more pushed upwards than this side here. It's not a problem for the assembly itself, it just doesn't look good as all, but the assembly runs really smooth. You can just turn this with one hand and turn it up and down, and this isn't even lubricated or anything yet. So I'm going to put some grease on the lead screw here, but that runs really good. I mean, if you can push it up and down this easily, I think you have a pretty good alignment all the way up and down. So I'm pretty happy with that. So here are the 2 blocks, and I had to make 2 of these blocks because I didn't have a stock that was thick enough or had any of the dimensions that I needed, because I needed to be, these dimensions needed to be correct, the length of it needed to be correct, because I needed to have a big enough surface area for the 4 screws to go in, so they would have enough grip on this tray here, so it wouldn't like turn on itself and block the rail rods which I have down here. And it's actually a pretty tricky setup, and you'll probably see it in the time lapse, but this top block is mounted to this thing first by driving a screw through the block, then through the 4 feet right here, and then tightening down to this part here, then turn over the whole thing, put it on top of the bottom block, and then drive the screw through this and this block into the carriage down here, like that. It's a bit tricky to set it up, but it does get the job done, and it's very, very sturdy. No flex in it whatsoever. So I'll hope that it will end up pretty damn good. That's the other one. Let's see if we can get the focus on it. A little booger ran off one of my cables. Gonna have to steal that back from him. This tab is pretty nasty. I'm gonna have to clean this whole thing out. It's full of dust and goo. So I finally got into cleaning out my power supplies here. And I'm using 2 power supplies in this case, and you do not have to do this. It's just something I figured as a fun little add-on project onto the whole thing. But this is actually a chassis out of a Dell workstation, one of those higher tier workstations who have like double power supplies. They're basically servers in a workstation desktop for under your desk or something like that. So they're very comparable to a server machine, and most of the time they do have an extra like graphics card if you're doing more advanced graphical stuff on your desk. But the good part in this is these are 700 watt power supplies. They provide like 58 amperage, 58 amps on the 12 volt rail. It's a single rail design in these, so that gives me quite a bit of usefulness out of these power supplies. And I would probably, well, definitely have enough with one power supply. I think I come up to like the maximum peak usage of 22-24 amps on 12 volts. These provide a bunch more. Now, why am I using 2 of these babies here? Is this case actually has a print card that load balances the power over the 2 power supplies, and when one of the power supplies fails, it will just jump over to the second one, and the machine itself will not stop working. That's what this print does. So I can actually have a power supply failure, and my printer will not have any problems with that and just keep on printing. And I can just swap it out for another one because I have more of these lying about. You can get them very easy as well. Just go online on eBay or something and find one of those older workstations, pick them up, screw out this power supply. You can get those freaking cheap because nobody wants them anymore. The CPU power in them is nothing, because most of the time they're like 771 sockets. They're old, but the power supplies are still great. I mean, buying one of these, just like 30 amps, would cost me 60 euros or something. So I had this lying around, unscrewed it, cleaned it out. I think this is going to work really well. What I'm going to do is, this is going to be mounted like this onto the chassis, and I'm going to 3D print me a plate that fits over here, so no one can reach in there and shock himself, or even worse, kill the electronics on it. And then the air is going to be pulled in this vent and go all to the back and exhausted here. So I think that's going to work out well, and I'll keep you guys up to date. Got the power supply mounted up to the side of the chassis of the whole thing. And in case you're wondering, I did reinforce this whole panel right here. There are L brackets underneath the foam, so it does flex, but it's sturdy enough to hold all the weight of all the components I'm going to mount to it. I did have to take off the board, the controller board, which is now laying right here. I know it should be in an anesthetic bag, but hey, who cares? I'm also mounted up the motor, the new axis. Works really well though. Gotta print me some new of those knobs, because these are annoying. A little bit more about this little board right here. This is a CNC board actually. It's not a printer board, and although it's almost fairly similar to a printer board, this does have a couple of downsides. I mean, it does not have the capability of reading out temperature sensors. It doesn't have a lot of extra outputs that you can use, unlike a RAM port or an Arduino, but it has enough, so I'll be able to switch a lot of things with it. And I'll probably get some separate temperature probes connected to it for now, until I'm able to buy a RAMS 1.4, which then I'll probably rebuild a bit to make it better, because I heard there are a couple of bugs with that one. But yeah, this, I would not recommend using this for a 3D printer. It's expensive,
and it's not the best option at all. I mean, this thing costs like 100 euros just for this board, and if you want to buy add-ons like a SD card reader, the SD card reader itself is like 25 euros if you want to get it from the official retailer, which is just insane. And I've not actually been able to find one from a third party. And it doesn't have a feature for adding on a display on it natively. I've seen there's like a hacked version to add a display on it, but it's a pain in the ass. I'll have to make my own printer and everything. So I don't know if I'll be spending the time on that one. I'll probably end up buying a RAM's 1.4 and just modifying that one. But yeah, so that's all the footage I've got for today, guys. I hope you enjoyed it. And I need to get this all in a better format. I need to get this done, this stuff worked into a video much better instead of just mashing up a couple of parts of videos that I made randomly at random times. So I'll see if I can do that better in the future. Well, see you guys later, and hope to see you again.